starting. All attendees are in listen-only mode.
Well, good evening, everyone. I'm meteorologist Rodney Chai, and together with me is meteorologist Rob Magnia, and together we'll be presenting to you the 2021 Atlantic Hurricane Season Outlook. And this webinar will be recorded and be posted to our YouTube page after the webinar. And all attendees will be on listen-only mode. And if you have questions for us, feel free to use the chat box to type in your question, and we'll answer the questions at the end of the webinar. And we'll be starting in a couple of minutes. Thank you very much. Well, good evening, everyone. My name is meteorologist Rodney Chai, and I work for National Weather Service in Boston Northern. And together with me is my colleague, meteorologist Rob Magnia. And together we'll be presenting to you the 2021 Atlantic Hurricane Season Outlook. And as I've said before, everyone is on listen-only mode. And but feel free to put in your question in the chat box. And also, we would love your feedback. So Joe is not able to be with us tonight because he's attending his daughter's reward ceremony. So Rob and I will be holding down the fort today, this evening. And so as I've said, today the topic is 2021 Atlantic Hurricane Season Outlook. And thank you so much for attending the webinar. And also, at the end of the webinar, Rob will be giving us the weather briefing, what to expect for the upcoming week. And so here are the presenters, myself, Rodney Chai, and my colleague, Rob Magnia. And here are the upcoming webinars. You can always find the latest webinars on our homepage, weather.gov/Boston/webinars. And our YouTube page is listed below. And you can, if you happen to miss any of our webinars, you can always go to our YouTube page to see the recording. And taking a glimpse at the upcoming webinars. So next week we have, next Tuesday, same time, 7 p.m., we have the new normals, and we'll talk to you about the new 30-year climate averages, which come about every 10 years. And if you notice like how some people talk about how the average snowfall in Boston has gone up with the new climate normals, and that has a lot to do with the pretty prolific decade that we just had, 2011 to 2020. And if you're interested, be sure to sign up for that webinar. And then after that, we have our Storms Damage Survey 101. And, join us as we show you how we conduct storm damage surveys, especially with the onset of the severe weather season. And also topics for future webinars, Jetstream 101, and then an intermediate introduction to weather and weather forecasting, weather models 101, and we would have our second installment of Meet the NWS Boston South, and also and future event reviews. And be sure to let us know if you have any new ideas or topics that you would like us to cover. Be sure to send Joe an email or let us know on social media. And so going to tonight's topic, tracking the tropics. So, the tropics is just barely getting started. June 1st is the official start date for the tropical season. It runs through November, and the hurricane specialists, they are located at the National Hurricane Center in Miami, Florida. And their primary role is to develop, coordinate, and issue tropical cyclone warnings, forecasts, and outlooks in different formats. And as for us here at the Northern Office in Massachusetts, our role is to provide the current information and be the local focal point for disseminating warnings and watches to all of you in southern New England. So we do work hand in hand with the NHC in Miami, Florida, and as well as the neighboring offices when we have a potential tropical event. And so let's go. Let's define what is a hurricane. A hurricane is a type of tropical cyclone which forms over the warm waters of the tropics, and it has a close counterclockwise surface circulation in the northern hemisphere, and it would be the opposite in the southern hemisphere. And around the center of the hurricane or the tropical cyclone, there will usually be thunderstorms or convection, and this has no association with a frontal boundary. So it's formed in the tropics, but as it gets caught up with the jet stream as it meanders further north, it may undergo what we call a transition to post tropical cyclone. But by then, it's no longer a tropical cyclone. So that's what we call when the hurricane loses its tropical characteristics. So here are the ingredients for the formation of a hurricane. So obviously you need warm water, and sea surface temperature, typically we're looking for over 80 degrees Fahrenheit, deep tropical moisture, latent heat release, and also light wind shear. So if the wind shear is basically the change in speed and direction of wind with height. So if you have, how in severe weather, we like to look for environments with high wind shear, but it is the opposite for hurricanes. You want low, light wind shear because otherwise the hurricane is going to be sheared out and it's going to weaken. So you need all these factors to come into play for a hurricane to form and sustain itself. And so what happens when the water temperature is at least 80 degrees Fahrenheit? Basically warm air rises and then it cools and condenses into liquid droplets, and then but as the ocean, especially a warm ocean, is a constant supply of basically heat energy, and and over time this warm air continues to rise, and then it basically generates wind energy, and then that is under the right conditions, as we talked about earlier, a tropical cyclone is formed. So the hurricane season, like I said earlier, it runs from June 1st to November 30th. But the height of the hurricane season, it really comes about between August and October, and it peaks in September. And that's when the ocean temperature is the warmest, especially in the in the deep south and the waters of the mid-Atlantic states. And statistically speaking, 2/3 of hurricanes form after August 28. And these are the names of the tropical systems that are provided by the National Hurricane Center. And an interesting fact is that the NHC began formally naming storms in 1950. And so they are named in alphabetical order. And they're typically female names, although in recent years they've also alternated between male and female names. And usually if a hurricane has caused a lot of damage, the NHC would retire that name and it would no longer be used in the future. And so highlighted in the red box is the names of the hurricane that will be used by NHC this year to name tropical systems. And then on the left, you can see the names that were used in last year. And we had such an active year last year that, after Wilfred, it went to Greek alphabets. And so that's when you run out of names, you go into alpha, beta, and so on. So hopefully this year we wouldn't run out of names. And this is the Saffir-Simpson scale, and basically it is the scale that the NHC uses to categorize hurricanes. And the primary determinator here is the 1 minute sustained wind speed. So basically in miles per hour, so Cat 1 hurricane is 74 to 95 miles per hour. If it is below 74 miles per hour, it is a tropical storm. And then Cat 2, 3, 4, and 5 are shown below. And then on the right column, those are the examples of the hurricanes and their category system. And the scale is approximately proportional to potential property damage. So obviously, the higher the category, the more damage that the hurricanes will probably have produced. And this is another graphic to show you the expected damage associated with the hurricane category, or below 74 miles per hour, it is a tropical storm. And so one thing to bear in mind is that if the sustained wind speed exceeds 110 miles per hour or 95 knots, it is a major hurricane. So Cat 3 to 5, that's major hurricanes. And so for us here in New England, we really spend. Yeah, go ahead.
Sorry. Hey, so we had a request, and I didn't notice this everyone until now, but I'm not sure what it is on your end, but we're not seeing a full screen of the PowerPoint. We're just kind of seeing your browser.
Okay, let me just make sure. Thank you for the feedback. Let's see. How about this now?
Yeah, I can still just see your browser.
You can just see the browser. Okay, let me make sure that it's. I apologize for that. Let's see. Make sure that it's. So you are not able to see any of the slides at all?
We can see the slides, but it's just not in full screen.
Okay.
So we can see all the other slides on the side as well as the main one.
Okay. Let's see. It's really interesting. Let me just see if I can pause this show screen. Let me try to fix that.
Are you on dual screens or just one?
Just one screen. Yeah, it's a Windows computer. Let's see. I'm just.
I think if you just click present at the top of the Google Slides bar, it should go into full screen.
Yeah, for some reason I couldn't find the top bar right now. Let's see. Okay, let's see. Okay, I see that now. Yeah. Okay, let me show screen. How about this? Is this much better?
Yeah, there we go.
Okay.
Thank you, Rodney.
Okay. And apologies, this is my first time doing this GoToWebinar, so I appreciate the feedback. So I'll just run through the slides here. Let's see. Okay. I just want to show you, here's again the Saffir-Simpson scale, my full screen mode, and once again, these are the categories of the tropical system, and then the bottom row shows how much damage you can expect with each category. And so for us here in southern New England, we are really interested in the development of tropical systems in the Bahamas, and we keep a close eye on that area. And typically, you can see in this spaghetti plot, each of these lines are basically tropical systems that formed in the Bahamas, and then it went up the Mid-Atlantic coast and impacted New England in one way or another. And that's showing 1900 to 2004. So looking at climatology, so June, here we are in June, and so on average about one storm every other year, and most June storms form in the Northwest Caribbean Sea or the Gulf of Mexico. So in June is not a very favorable month for us if you want to see tropical systems in New England. But then when we get to July, as the ocean waters warm, the threat spreads east and it covers the Western Atlantic, Caribbean, and Gulf of Mexico in terms of the origin of the tropical cyclone. But you can see the threat area starts creeping further east and north. And then when it gets to August, notice you have the swath of green shading that depicts more likely formation and of the tropical system, and getting into New England. But the most likely area, as depicted by orange, is still points further south. So so August we are getting into the business end of the tropical season. But September is really I would say the peak climatology for tropical systems, and not just for New England, but really everywhere, anywhere from the Gulf of Mexico coast up the Atlantic seaboard, and basically storms can form anywhere in the basin. And here you basically have a large swath of green and orange depicting more likely formation of the tropical systems. And then in October, as the ocean temperature starts to cool, and then you get stronger cold fronts from the north, it starts to wane a little bit, but still the threat is still there. So the development area shifts back to the Gulf, Caribbean, and Western Atlantic. in November, that's the threat really drops off as temperature continue to fall. So hurricane return periods. So what does it mean? So on average, a hurricane would track within 50 miles of southern New England every 13 to 18 years. And so the last landfalling hurricane was Hurricane Bob in 1991. So based on the climatology, we are due for a landfalling hurricane. Not to say it will happen anytime soon, but based on the numbers, we are due for one. So hopefully it's not this year. Well, but we'll see. And as for major hurricane return periods, so remember, major hurricanes is you're talking about sustained wind speed above 110 miles per hour or 95 knots, or Category 3. And the last major landfalling hurricane in New England was Major Hurricane Carol in 1954. And that, on average, a major hurricane would track near southern New England every 50 to 70 years. And this was just a snapshot of a satellite image showing just how active 2020 Atlantic hurricane season was. And you can see, Sally, Paulette, Renee, Teddy on the satellite image at the same time. So it really shows you, it's just, if you live, in the Gulf Coast or the Deep South, last year was a very rough hurricane season for you because, you just have one hurricane or tropical system after another. So 2020 season got up to an early and rapid start with a record 9 named storms from May through July. And remember, the official season only starts on June 1st. So the NHC actually had to start issuing advisories prior to the official start of the hurricane season. And then the names were quickly exhausted. And, once Tropical Storm Wilfred formed, in September, and so for only the second time in history, the Greek alphabet was used for the remainder of the season, extending through the 9th name in the list. And this is a graphical overlook of the names that were used in 2020, and you can see, just a lot of names, and we have to basically go through the 9 Greek alphabet before the season was done. And this is yet another graphic showing you just how prolific 2020 was for the Atlantic hurricane season. And one quick thing to note is that notice the second column, the Noaa Hurricane Hunters. So they have a very cool name, but they serve an important role to do recce of, let's say if the NHC is forecasting a tropical system to impact a large part of the United States, the hurricane hunters, basically they fly the planes into the young tropical system, which may be in the Bahamas, and then they would take measurements of the low pressure system, and that ground truth will be fed into the models so that we get better and more accurate forecasts for the potential tropical system or hurricane. So they serve a very important role, hurricane hunters. And this is just a quick look at Hurricane Laura approaching the Gulf Coast, and you can see that well-defined eye. And so when you can see such a well-defined eye, it shows you how powerful that tropical system, or in this case hurricane, is, and unfortunately caused a lot of damage for the Gulf Coast. So at this point, I will pass it to my colleague Rob Magnier to talk about the 2021 Atlantic Basin hurricane forecast.
All right, thank you, Rodney. And fun fact, before I got hired here at the forecast office in Boston, I was actually working at the forecast office in Lake Charles, Louisiana, which is where Hurricane Laura, which you saw on the last slide, made landfall. And fortunately, I got hired about 2 weeks before Laura made landfall, and I got out of there and really dodged a bullet. So hoping we don't see another storm like that this year. So before we get into the Atlantic Basin hurricane forecast, just a reminder to the coastal residents that it only takes one landfalling storm for it to be an active season. And it's always good to be prepared regardless of the forecast. If you recall back in 1992 when Hurricane Andrew made landfall in Florida as a Category 5 hurricane, that was one of the least active hurricane seasons on record. There were only 7 total named storms in that season, but it only took one in Hurricane Andrew to make it memorable. Next slide. Oh, back one. Oh, okay. Sorry. Okay, what's new for this season? So 2 things new for this season. So as some of you may know, we had some new climate normals released. So there's now a new normal for what is considered a normal Atlantic hurricane season, and the new normal is higher than it was for the averages that we were previously using from 1981 to 2010. So now we've jumped from 1991 to 2020, and that's going to be the new normal for the 2021 season. And also something kind of new this season, usually and still officially, Atlantic hurricane season starts on June 1st, but this year the the National Hurricane Center started issuing Atlantic tropical weather outlooks as early as May 15th. So those are the 2 new things heading into the season. So one of the reasons we wanted to hold this webinar is because these forecasts come out every year, and we kind of figured a lot of people might be curious on how you can make a forecast like that 6 months in advance. So 2 of the things that climatologists use to make these predictions are kind of the number one being predictions of large-scale climate factors and that are known to influence seasonal hurricane activity. So for example, El Nino or the Atlantic multi-decadal oscillations. These are what are called teleconnections, and these can be forecast, weeks or months in advance. So it gives forecasters an advantage for making a forecast 6 months out. And then we also have our numerical weather prediction models that can go out in long ranges in some cases to make predictions for specific variables. And one of the more commonly known ones is the CFS model, which is just a climate forecast system. So it's a combination of both prediction of large-scale factors as well as numerical weather prediction as well. Next slide. So some of the challenges in forecasting the activity for the Atlantic hurricane season, number one is predicting the El Nino and La Nina events. Those are, kind of a starting point for what to expect for the Atlantic hurricane season, and making those predictions, 4 to 6 months in advance can be challenging. And also, even if you're able to kind of nail down what the climate conditions are going to be like this upcoming fall during peak hurricane season, there's still many combinations of named storms and hurricanes that can occur for the same general set of climate conditions. So that introduces a challenge as well. And of course, I mentioned that we use numerical weather prediction, our computer models, to make predictions. And as Rodney had discussed, some of the ingredients are sea surface temperatures and vertical wind shear and moisture. And these models have very limited skill in being able to predict these variables, 4 to 6 months in advance. And then probably one of the greatest challenges is we have no clue what kind of shorter term weather patterns are going to be on the horizon. They're very unpredictable, and these can often have an impact on hurricane season and hurricane activity during the peak months. And when these shorter term weather patterns pop up, they can produce impacts for a period of weeks or more. So maybe as an example, sometimes in late summer, early fall, we start to hear about the Saharan dust, which can spill out over the Atlantic and suppress hurricane activity. But that's not something we can really predict this far out. So those are some of the number of challenges we face when we're making these forecasts. So with that, we'll go into the hurricane season outlook. And again, just a reminder, what this outlook is, it's a general guide to the expected overall activity during the upcoming hurricane season. It is not a seasonal hurricane landfall forecast and does not predict levels of activity for any particular location other than the Atlantic Ocean as a whole. So our friends at the Climate Prediction Center, they came out with this Atlantic hurricane season outlook, which right now is calling for a 60% chance of above normal activity, 30% chance of near normal, and only a 10% chance of a below normal season. So there's high confidence that we will not be dealing with a below normal season. And as far as specifics go, the forecast called for 13 to 20 named storms, 6 to 10 hurricanes, with 3 to 5 being major hurricanes. Next slide. So again, you're kind of seeing the same numbers again on this slide, but what I wanted to show was this parameter that is used to come up with the number of named storms and hurricanes, which is called ACE, which stands for Accumulated Cyclone Energy. And that's a parameter that measures the overall strength of a hurricane season. And usually this number is derived from a combination of statistical and dynamical models. And depending on what they get is kind of how they get these numbers for named storms, hurricanes, and major hurricanes. So when they ran the models, they essentially found that the median ACE they came up with was between 110 and 190% of the normal hurricane season. So if this were to verify on the lower end of 110%, we'd probably be more likely to see 13 named storms, 6 hurricanes, 3 major hurricanes. But if we're on the upper end towards that 190%, it would be closer to 20 named storms, 10 hurricanes, and 5 major hurricanes. So it's that ACE parameter that is kind of a big factor in how these numbers are determined. So now we'll talk about the science behind the outlook, what came about for them to arrive at this conclusion. And as I said earlier, one of the big things they look at is El Nino and La Nina influence, or ENSO, which stands for the El Nino Southern Oscillation, which is just the formal name for the El Nino teleconnection. And for those of you who may not have tuned into our global weather patterns webinar or aren't as familiar with El Nino, all it is it's basically just a measure of sea surface temperature anomalies that occur over the equatorial Pacific. And when those ocean waters are warmer than normal, that's considered an El Nino episode. And when they're colder than normal, it's considered a La Nina episode. So in this diagram, we have an El Nino episode where sea surface temperatures over the equatorial Pacific are warmer than normal. And this is usually a suppressor to the Atlantic hurricane season because typically during El Nino, we tend to see stronger vertical wind shear and easterly trade winds over the Atlantic Basin, as well as greater atmospheric stability. And of course, as Rodney had mentioned, we don't want a lot of wind shear and we need a lot of instability. So El Nino is usually a suppressor to the Atlantic hurricane season. And on the other side, in the Pacific Ocean, that's when things tend to be a little bit more active for them, is during El Nino episodes. So then, of course, the counterpart, La Nina, which is what we were in last summer, tends to enhance hurricane season because it essentially just has the opposite effect. During La Nina, you have cooler, drier conditions over the Pacific, and that supports weaker vertical wind shear and more instability over the Atlantic Ocean, which is going to be supportive of tropical cyclone development. So this is kind of a loop of El Nino current conditions. So what you're looking at is sea surface temperature anomalies on a weekly basis from March through May. with the blue shading kind of representing cooler than normal sea surface temperatures and the red shading representing warmer than normal sea surface temperatures. So you want to just attract your attention to basically the center of the graphic where the equator is, and you can see it's not really leaning one way or another as you get towards May. So the Climate Prediction Center has actually come out and determined that La Nina, which we were in for a lot of last season, has come to an end, and we're now in ENSO neutral conditions. And the forecast is for that to continue at least through the end of the summer with 67% confidence. But looking beyond the end of the summer, we can rely on a combination of dynamical and statistical models to come up with a forecast. So on the horizontal axis, you're kind of seeing 3-month periods, and you want to direct your attention to where the red arrow is pointing, which kind of represents the August, September, October period, which is peak hurricane season. And all these little line graphs represent each of the dynamical and statistical models that are listed on the right side of the graphic. So what's being done here is they're taking what's called an ensemble approach. So rather than relying on one model, they look at these dozens of models and see if a group of them they take the consensus forecast, so to speak. So you can see most of the models are zoning in on neutral El Nino conditions, or maybe even a little bit below neutral for peak hurricane season. So this is kind of what is enhancing the confidence that will be either in El Nino neutral conditions or possibly a weak La Nina during the peak months of hurricane season. So in addition, we also have our numerical weather prediction models. Like I mentioned at the beginning of the presentation, the CFS, the Climate Forecast System, and Noaa also has the North American Multi-Model Ensemble that can directly predict sea surface temperatures for peak hurricane season between August and October. And each of them right now are both predicting neutral conditions, so sea surface temperatures around normal for that area. And similarly, these models can make predictions for wind shear or anomalous wind shear forecast because, as Rodney had mentioned, we don't want a lot of wind shear if we want hurricane development, which of course we don't. We'd probably rather see higher than normal wind shear. But in this case, we're seeing below average wind shear predicted by both the Climate Forecast System and the North American Multi-Model Ensemble in what's known as the Atlantic Main Development Region, which is the rectangle you see there across the southern Atlantic waters. So kind of wrapping up the ENSO part of the forecast, based on all of these model forecasts and forecasts of the sea surface temperatures in the equatorial Pacific, the Climate Prediction Center decided that there was going to be about a 50% chance of ENSO neutral conditions during the peak months, August, September, October of hurricane season, followed by a 42% chance of La Nina and only an 8% chance of El Nino. So in terms of the current hurricane season outlook, the expectation is that El Nino will likely either not compete with or will reinforce, in the case that we get a La Nina episode, the ongoing set of conditions associated with the current high activity era for Atlantic hurricanes. And high activity area is a term I'm going to discuss in a couple of slides. So in addition to seeing what's going on in the equatorial Pacific to find out what El Nino or La Nina status is, you also have to look at where the action is going to be during the hurricane season in the main development region that I mentioned on the last slide. So this is another area where we're going to make forecasts for sea surface temperatures and wind shear directly as well. So the predicted conditions within the MDR. So as of April, just a few weeks or a couple months ago, sea surface temperatures in the main development region were right around average. And again, we saw this on a previous slide, but now we're going to focus our attention to the Atlantic waters. Both the climate forecast system and the North American multi-model ensemble are both predicting sea surface temperatures in the main development region to be anywhere from 0 to 1 degree Celsius above normal. And the average was about 0.3 degrees above normal sea surface temperatures for the Atlantic main development region, which is going to be favorable for cyclone development. So again, that high activity era that I mentioned at the end of the El Nino wrap up, so that refers to another teleconnection that is looked at and monitored for activity during the Atlantic hurricane season. That's the Atlantic Multi-Decadal Oscillation. And this teleconnection just refers to variability in the sea surface temperature of the North Atlantic Ocean on the timescale of several decades. And I believe since 1995, we've actually been in the warm or positive phase of the AMO, which is also known as the high activity era. And under these conditions, you tend to have warmer sea surface temperatures in the Atlantic main development region and a stronger, wetter West African monsoon, which I'm going to discuss in a little bit. And then on the opposite side, the low activity era is essentially just the opposite, where you have cooler ocean temperatures and a weaker West African monsoon. So the high activity era conditions are more favorable for hurricane activity, as I mentioned on the last slide, for the reasons being that it favors above average sea surface temperatures, and typically you're going to have near or weaker than average vertical wind shear and weaker easterly trade winds and vertical wind shear on the eastern side of the MDR, and again typically associated with a stronger and wetter West African monsoon. And the expectation is that this is going to be ongoing, and it's going to continue into the Atlantic hurricane season. So the West African monsoon that I mentioned, so there's other ways that we can try and predict how the West African monsoon is going to behave. And if we can get an idea about that, it can reinforce our thinking that the high activity era is going to continue, since the high activity era is associated with a stronger West African monsoon. So looking at westerly anomalies, basically just looking at wind speeds in kind of the mid-levels over portions of southwestern Africa. Typically, if you have above average westerly winds, you're going to tend to have weaker easterly trade winds, and that's going to be consistent with a warm phase Atlantic multi-decadal oscillation or the high activity era, and that's going to give you an enhanced West African monsoon. And then on the bottom, we're looking at another parameter called divergence, or the divergent wind, way in the upper atmosphere. And this is another one that is commonly looked at to determine what the activity of the West African monsoon may be in a few months. So this just covers a period from early April through early May, and we're looking at anomalous divergence over Africa, and that's going to suggest an early start to the West African monsoon, further supporting the fact that we're going to continue that high activity era in the Atlantic. So again, with the enhanced West African monsoon, what this is going to do to support more activity in the Atlantic Basin, anomalously warm sea surface temperatures and decreased vertical wind shear, an African easterly jet structure that favors increased rotation of low pressure cloud systems, which are also known as African easterly waves, moving westward from Africa. And African easterly waves are essentially the very early stages for most Atlantic hurricanes. So once you get those African easterly waves moving westward across the Atlantic, if the conditions are favorable, they'll develop into a tropical cyclone. And it also will enhance the combination of increased moisture and decreased stability. So overall, this is going to enhance the likelihood of African easterly waves developing into tropical storms and potentially hurricanes. So that pretty much wraps up the forecast, and kind of really the only big uncertainty right now is, are we going to be in ENSO neutral conditions, or are we going to be in La Nina conditions come peak hurricane season? Because as you recall, there was about a 50% chance of ENSO neutral and a 42% chance of La Nina. So it's really on the fence there, and depending on what happens, we could see ENSO neutral either neither suppress nor enhance activity in the Atlantic, or we could see La Nina potentially enhance activity. So what ends up happening here will kind of determine whether or not we're on the lower bound or upper bound of the forecast. So if we're in ENSO neutral, and that's kind of where they're leaning towards right now, we may be on the lower end with 13 named storms, 6 hurricanes, and 3 major hurricanes. But if those temperatures in the equatorial Pacific cool down a little bit and we get back to a La Nina, we could be on the upper bound of this forecast. So hopefully that doesn't happen. So that's all we have today for the tropical Atlantic hurricane season outlook. For more information on all things tropical, or if you want to see what's going on in the tropics, you can visit our tropical webpage at weather.gov/Boston/tropical. And there you'll find links to the National Hurricane Center as well, and to some of their products and outlooks. And I guess with that, before we start the briefing, Rodney and I would be happy to take any questions.
Okay, thank you so much, Rob, and thank you so much for listening to the webinar. But let's take a look at what questions we have. So, see, we have lots of questions, which is great. And we will take time to answer them. So, the first question is by Robert. So most strong hurricanes seem to go extratropical just before they hit southern New England. With warming oceans, will this continue, or will hurricanes maintain their tropical characteristics? So I'm going to take a stab at this one. So, with warming oceans, and I think if I interpret your question correctly, Robert, that's associated with climate change, and one of the key factors of the formation of tropical cyclones and its being able to maintain or strengthen is the ocean temperature, and specifically above 80 degrees Fahrenheit. And so, yes, with warming oceans, the hurricanes will be able to maintain their tropical characteristics up to a more northern latitude. So, so the answer is yes. And so the second question. Let's see. Okay. So this one is by Gary. So is the Saffir-Simpson scale used, and is it the same criteria for rating cyclones in the southern hemisphere? Rob, do you want to answer that question?
I honestly don't know. Okay. I've been stumped. My guess is they probably do. We try to keep things consistent in the field of meteorology, but I can't confirm whether or not they do in the southern hemisphere.
Yeah, I would concur with Rob as well. We'll get back. If you have a follow-up question, be sure to feel free to email us, or email us, or even contact us on social media. We'll be sure to answer your question. But right now, I think that's the best answer we can give you right now. And the next question, and this is actually a comment from Ronald. So I'm sure you folks are aware of this, but this August is the 30th anniversary of Hurricane Bob in southern New England. Yes, so Hurricane Bob made landfall in 1991, and that was the last landfalling hurricane in southern New England. Okay, so question from Richard. Please explain the tidal surge funneling effect. So try to take a stab at this one. Oh, go ahead. Yeah.
The completed questions. So I think he entered it twice. The first time was incomplete, but the complete questions is a couple below that.
Okay, I see. Yeah. So I see. Please explain the tidal surge funneling effect in Narragansett and Buzzards Bay, especially when a hurricane passes to the west of Rhode Island, coinciding at an incoming tide or high tide, producing strong hurricane winds from the south and southeast. And yeah, Richard, that's a great question. And so Narragansett Bay. So for those of you who are not familiar with the geography of Rhode Island, you know that basically if you have a storm surge, coming in from the south, that funneling effect is when you have like a. So think of it this way: when you have like a wide body of water trying to be squeezed into a narrow channel. All this water has to go somewhere, and when you get squeezed into a narrow channel, the result is higher surge, and so that puts places like Providence under the gun and under the right conditions, and for those of you who are not familiar with the area, that's actually a hurricane barrier at the mouth of the Narragansett Bay, and also in places like New Bedford, and that's the purpose is to try to prevent a devastating storm surge. And Rob, do you have anything to add?
Yeah, so I'll just add to the part of the question where especially if the hurricane passes west of Rhode Island. So storm surge is typically the highest on the east side of hurricanes, because if you think about the counterclockwise rotation and the motion of the storm moving south to north, those two are going to be working in tandem together. So if you were on the west side, the winds would be coming from the north versus basically going in the opposite direction of the storm speed. So you typically have a little bit less surge on the western side of the storm. So yeah, that is kind of the sweet spot for Buzzards Bay and Narragansett if you were to get the eye of the storm moving just to the west. So that's the east side where all the surge is going into Narragansett Bay and Rhode Island. And then, of course, if you just add the natural tide cycle, and it happens at high tide, you're just adding even more to what we call the total water level, which is basically just a combination of the astronomical tide, the storm surge, and any of the waves that might be occurring on top of that storm surge.
Well, thank you so much, Rob. So the next question is, will the eruption of the volcano on St. Vincent Island in the Caribbean have any impact on tropical systems development in the Caribbean? And that's from John. What do you think, Rob?
I don't know the answer, but I briefly remember hearing about this, and I think the expectation is that it wasn't going to be big enough to have a significant impact. But another part of me remembers them saying they were uncertain. So I guess I'll probably run with the uncertain what kind of impacts it will have, because large-scale volcanic eruptions can definitely have an impact on all weather, including the hurricane season.
That sounds good. Yeah, thanks. And the next question is from Ronald. Is it true that the 2021 Atlantic hurricane season forecast is partly based on the lack of El Nino, as we also had last year? Rob, do you want to I'll try to answer this question.
Yeah. So in fact, it's largely based on the lack of El Nino. A big portion of the forecast came from the fact that we were going to be in either El Nino neutral conditions or La Nina, which is what can definitely be thought of as the lack of El Nino. It's just the opposite. So that is one of the big reasons why our friends at the Climate Prediction Center arrived at the forecast they arrived at.
Okay, thank you. And also another question from Ron. Are there any pattern indicators that occur, say in the spring and summer here in southern New England, that may raise a red flag that southern New England may be in for a landfalling hurricane? And I think that's a very difficult question to answer, Ron. I would say it would almost be a wild guess if I think, at least in my opinion, climatology speaking and based on the return rate, we are due for one, but it's almost impossible to say if it's going to happen this season or next year. And Rob, do you have anything to add to that question?
Yeah. I mean, I'll just say, Ron, that we're not there yet as far as the science and being able to forecast where we might expect landfalling storms to be. I think there is some research, some promising research right now where they're making predictions with some degree of accuracy for landfalls in like very, very broad locations. For example, probability that the entire Gulf Coast will see a landfalling storm, or the entire East Coast will see a landfalling storm, or the islands in the Caribbean and Cuba will see a landfalling storm. I think that's about as far as the research has gone, but we're not anywhere close to being able to pin down the probability of a landfalling storm in an area as small as southern New England.
Well, thank you. And this one is from Landon. How is ACE calculated? And ACE is accumulated cyclone energy.
I actually don't know that off the top of my head. I'd have to go and read the paper. And if anyone's interested, the Colorado State University, who has their own Atlantic hurricane season outlook, they go into this in a lot greater detail, their forecast as well as ACE. But I believe it has to do with the period of length of wind speeds within a storm. So, if a Category 3 storm lasts for, 24 hours, there's a certain amount of accumulated cyclone energy associated with that. So I think it is derived from time and wind speed, but I don't know the exact formula.
Yeah, Rob, I think that's a great answer. And just looking on Wikipedia, that's basically you nailed the definition of ACE. So great job and great question, Landon. And also another question from Landon. So what causes El Nino and La Nina?
You want me to take that one?
Yeah, go for it, Rob.
Okay. So El Nino and La Nina are driven by natural variability in the easterly and westerly trade winds, which are just a part of the global circulation towards the equator. And when the easterlies are stronger, I believe, you tend to have more of a La Nina episode. And what that has to do with is, if you kind of think about easterly winds over the equator, if they're stronger, they're going to push warmer water at the surface further westward. And as a result, that warmer water has to be replaced. So cold water comes up from underneath in a process called Ekman upwelling. And when you have that cold water coming up during stronger easterly trade winds, that's when you get a La Nina. But when the trade winds are weaker, you tend to have warmer sea surface temperatures down there in the equatorial Pacific. And that's when you get the El Nino episodes. And as far as, you could say, well, what causes fluctuations in the easterly trade winds? That's very up in the air, and it's an active area of research. It has been for a long time. But the best explanation is just low frequency natural variability. It's just a part of the Earth's cycle.
Yeah, that's a great explanation. Thank you so much, Rob. And once again, great question from Landon. Moving on to a question from Katie. Doesn't it usually take a while for the effect from a La Nina or El Nino event to make it over to the Atlantic to affect things like the hurricane season or, say, the winter snowfall in places like the Northeast. And if I understand your question correctly, Katie, you know, I think what you're trying to say is that the global weather pattern usually takes time, from the onset of, let's say, either warmer than average or cooler than average sea surface temperature anomalies in the Pacific Ocean. Yes, it does take time. There will be a mechanism of processes that has to take place in order to impact our weather here in southern New England. So it's not a direct impact. And Rob, what do you think?
I would say that's fairly accurate to a degree. There is a bit of a lag between when certain teleconnections go into different phases, or when El Nino goes into neutral or La Nina conditions. But I think that is monitored by like the Climate Prediction Center, and I think the expectation is that La Nina is over and we're in a new ENSO neutral conditions, and so what will come with that is it won't suppress Atlantic hurricane activity this upcoming season.
Okay, thank you, Rob. Another question from Landon, and Rob, I'll pass it to you as well. Is the tropical wave the same as the African easterly wave?
For the most part, yes. I think an African easterly, not all tropical waves are African easterly waves, but all African easterly waves are tropical waves, if that makes sense. African easterly wave, I guess, could be used to describe the origin of a particular tropical wave.
Okay, thank you. And this question is from Beth. On the slide showing the satellite view of the 2020 storms, why were they not in alphabetical order from west to east? In other words, why was the latest storm still west of an earlier storm? And Beth, the reason for that is because, yes, typically you would expect the storms to line up in order, but in this case, one of the storms formed later and to the west of an earlier system, and so that would be the explanation. And a follow-up comment from Beth. I thought the storms kind of march from west to east, so that is true, but partially because you kind of have to make the so the storm, let's say the tropical cyclone form in the Bahamas, and then they would actually track from east to west, but then the configuration of the jet stream would eventually force the storm to go to the northeast as it march, if we were to march up the Atlantic seaboard. So just going on, just making sure we stay on time. From Eric, so since most storms affecting the East Coast come from the west, what causes hurricanes to form out in the Atlantic Ocean and then head west towards the Caribbean or East Coast before changing directions towards northeast or out to Atlantic Ocean? And I think, Eric, the short answer to this question is, again, it has a lot to do with the interaction of the tropical system with the jet stream. And, even though the hurricane, may appear to be very huge and do a lot of damage, it is very small, minute in the grand scheme of things. And sometimes it's just by the stroke of luck, whether a hurricane gets into Gulf of Mexico or it rounds the bend and hits up the Atlantic seaboard, or it gets kicked out to sea. So it really depends on the synoptic conditions at that time, and a lot has to do with timing and the strength of that. That's when wind shear comes into play, and just there's a lot of things that go on into a tropical cyclone forecast. So hopefully that makes sense. And from Joanne, if you go to Greek names this year, does it start after Loda or back to A with new Greek names? And I believe that I do believe we start with A. We start all over again. Okay, let's see. From Wayne, what data, if any, do you have regarding the accuracy of your hurricane predictions? And I'm sure we can. I'm sure the NHC would have an archive. It's just like how we do verification of our forecast here at NWS Boston. The NHC would have their own verification matrix to see how well they perform. And let's see. So from Kate, can other clouds join onto hurricanes? And so basically, so let's step back and remind ourselves what is the definition of a hurricane or a tropical cyclone. So basically, it is a low pressure system, and where you have winds going counterclockwise around the low pressure system. And so you would have, if you look at the satellite image, you would have clouds kind of going around that eye. So if I understand your question correctly, so clouds can, are associated with hurricanes because ultimately you would have thunderstorms near the center of the circulation, and it's all part of the that configuration that give us the hurricane. Let's see. So so we have a comment here, actually a question on Buzzards Bay. My grandfather lost cottages in the 1938, 1944, and 1954 hurricanes. Why were these occurring so frequently at that time? And Hurricane Bob 30 years ago was the last one to bring major damage to that area. The quick answer to this question for me is I'm not sure. Probably have to look back at the climatology during that time. Rob, do you have anything to add to this question?
No, I mean, just like you said, uncertain. It's just luck of the draw.
Okay, no, thank you. So moving on, from John, what is the atmospheric pressure range of the center of circulation in a tropical storm? For example, Tropical Storm Blanca in eastern North Pacific Ocean. I believe that they go down to pretty low numbers, something along the ballpark of like 940, 950. They are pretty intense systems. And also, the lower the pressure, not always, but the lower the pressure in the center of circulation, the stronger the system, because ultimately you're talking about winds going around the eye of the hurricane. So, when people talk about the eye wall of the hurricane as it makes landfall, besides storm surge, the speed of the hurricane, of the sustained wind, would determine the category of the hurricane, and as well as, unfortunately, the amount of damage that it can cause. And from Ronald, a comment, I would also like to say kudos to Bill Leatham for creating that 1938 Hurricane Rick recreation using technology. I've been waiting a long time for someone to create such a program. Thank you so much for the comment. I will be sure to pass it on to Bill. And what are the origins of the names El Nino and La Nina? And this is a question from Kate. I don't know off the top of my head. I think it's like, if I'm not wrong, El Nino is a little boy in Spanish. Unless Rob wants to correct me.
Yes, no, you're right. El Nino is the boy and La Nina is the girl. I've heard a lot of mixed reviews about where this comes from, but the original origin I had heard was that hundreds of years ago, Peruvian fishermen would La Nina, you have colder waters off the west coast of South America, and typically colder waters have more nutrients. So during those times, there'd be better fishing years, and when it was warmer, there would be poor fishing years, so there would be more starvation. And again, this is what I had heard. The idea was the boy takes life. 100 years ago, men were fighting war, so the boy takes life, and La Nina, the girl, gives life because women give birth. That's the origin I had originally heard. I'm not 100% sure on the accuracy though. But Rodney, maybe a couple more questions, and then we can get to the briefing, because I think we're a little over time here.
Yes, yeah, I was about to say the same thing. And for those of you who have to leave, feel free, because it's after 8 p.m. And those of you who are staying with us, thank you so much for your time once again. So let's get a couple more questions, and then we will move on to the weather briefing. So let's see. So we have an interesting question from Sebastian. What would happen if two hurricanes collide? Would they rapidly strengthen and merge, or differing wind fields would tear them apart? Rob, do you want to take this question?
Sure. So I think that initially both storms would weaken, because if you have winds coming from different directions, you're going to have an increase in wind shear, which we know is poor for the life of a hurricane. But at one time, and usually I think this has been the case, one will take over another. It will eventually turn into one big low pressure system. And then given that the conditions are still favorable, you still have warm sea surface temperatures, and going into a new environment with weak vertical wind shear, you could get re-intensification. But initially, I believe the storms would weaken.
Well, thank you very much, Rob. And we'll get to one more question before the weather briefing. This one is from Landon. Some typhoons, such as Super Typhoon Haiyan, have central pressures in the low 900 millibar range. While this seems to be very uncommon for Atlantic hurricanes, why is this so? I would say that, and this is really my guess here, on the other side of the world, I mean, in Asia and the Asian continent, you have the Pacific Basin, and that basin is a lot larger than the Atlantic Basin, and if I'm not wrong, it's also warmer. And remember, warmer ocean temperature equate to potentially more energy that can be converted to kinetic energy of the wind field surrounding the hurricane, or the typhoon in this case. So, that may explain why the typhoons tend to have lower pressure, at the center of their circulation. But again, that's my guess here. So I think at this time, let's move on to the weather briefing, and then we'll let Rob take over the weather briefing. Let's see. Okay. Over.
All right, thanks. So yeah, just a quick overview for what to expect the next couple days. We're going to see some showers and thunderstorms overnight, particularly out in western Mass, Connecticut. Elsewhere across the interior and eastern Mass, you could maybe hear a rumble of thunder or see some showers. And then we'll get another pop-up of some afternoon showers and thunderstorms tomorrow as well. And as we head into the weekend, it's going to start to feel a lot more like summer. We're going to see increasing temperatures, and we may even have the potential for a heat wave early next week, which would be 3 days of 90 degrees or more. Next slide. So just taking a peek at this forecast tool we use, this is called a situational awareness table, and basically just goes back and looks at previous forecasts for a certain day. So for example, this was from Wednesday evening forward, and it kind of just gives you a perspective of what the forecast looks like relative to previous forecasts. So if you turn your attention to the top box, you see these 3 columns on the right. They basically just represent different parameters of moisture. And you see where it says max for tomorrow afternoon. So that just means, that's the highest moisture forecast for the Boston County warning area at this time of year. So it just kind of gives us a signal that there's going to be more moisture in the environment than normal, and we might need to pay attention if there's going to be some rainfall, and there could be the potential for some locally heavy rainfall overnight tonight with that increased moisture in specific areas, again, specifically out west. And then again, as I mentioned, we're going to go into a warming trend. So if you look in the second red box under the T column, which just stands for temperature, you can see several straight periods of max, again, meaning that this is the highest the temperature has been forecast at this time of year, just for the general area of New England and the Northeast, not for any one particular location. So just a high signal that we're in for an increase in temperatures early next week. So just a heads up too, this may have changed since this morning. I'm not sure Rodney was forecasting today, but we did have a marginal risk for excessive rainfall overnight for a little sliver of northwestern Massachusetts. So if any folks out there encounter some torrential rains, just be aware of that. But again, a very low marginal risk. And this is just an image of the 2-day rain totals valid for Saturday morning. So this includes rainfall we'll see tonight as well as tomorrow afternoon. And if you look across western Mass and Connecticut, you can see kind of a bullseye of maybe around an inch or more of rain, with locally higher amounts possible, and then amounts decreasing eastwards. So most of the heavy rain activity during overnight tonight and afternoon tomorrow will be focused out west. So this is just a loop of fronts and sea level pressure and high and low pressure systems for the next week. And as you can see, we kind of stay in a pretty persistent pattern. This Bermuda high pressure system just kind of sits off the East Coast, and the flow around that is clockwise. So it's just going to be pumping southwesterly flow, warm moist air into the region. So it's really going to start to feel like summer early next week. And with all the heat and humidity, if we have maybe any weak upper level disturbances passing through in the afternoon, we could maybe see a pop-up afternoon shower thunderstorm at some times during next week as well. And here is the high temperature forecast. So just for the next couple of days, we'll be around seasonal until we start to get into the weekend and early next week and see the temperatures jump up into the mid to upper 90s for Sunday, Monday, and Tuesday. So just a look at the high temperatures for maybe some of your areas for next week. And just the 6 to 10 day temperature outlook. So beyond next week, we have an 80% chance of above normal temperatures per the Climate Prediction Center. And beyond next week, we're looking at about a 33% chance of drier than normal conditions for the next 6 to 10 days. And then going out a little further, 8 to 14 day temperature outlook. Again, we're still got a 50% chance of above normal temperatures. So expect that warming trend to continue well into mid-June. And then finally, just wrapping up with the 8 to 14 day precipitation outlook, just right around normal for this time of year. But that is all we have for this evening. Thanks everyone for tuning in, and thank you, Rodney, for hosting. And any feedback, shoot Joe an email, and we'll see you again next time.
Well, thank you, Rob, and thank you everyone for attending. Have a great evening.